Systems of inequalities. So we're at the end of the chapter on systems of linear equations. And the solution to a system of equations is the point of intersection, yes? And if it has a point of intersection, in words, the solution is what? Name the solution if it's a single point of intersection. What type of solution is it? Consistent and independent. If the lines are parallel, there's no point of intersection, there's no solution, and the solution is called inconsistent. If the line is the same line, one on top of the other, the solution is the line, meaning every point on the line, and the solution is consistent and dependent. Okay, that's for lines. Now we're doing inequalities. Inequalities has tons of points to them. So, we'll go back and fill in the blank in a moment. Let's look at the example here. I've already graphed the green one. Guys, listen, you cannot leave Algebra 1 without y equals mx plus b firmly in your mind and know it like you know your birthday. I'm just telling you. You got to know y equals mx plus b like your birthday if you're going to get out of Algebra 1 knowing everything that you're supposed to know. You ninth graders that took the PSAT, was there a lot of y equals mx plus b on there? Yes. A ton. And if you didn't think there was that much, the problem was you weren't thinking y equals mx plus b. You got to know y equals mx plus b coming out of Algebra 1. M is the slope, b is the y-intercept. So for this one, what's the y-intercept? 1, right? We always graph that first. That's right there, right? What's our slope? 1 over 1. The top is what change of the slope, class? Vertical. You got to remember that. Top is up and down. Bottom is left and right. So I go from here up 1 and to the right 1. And look, lo and behold, I hit that point, right? Now, we've already graphed inequalities. Why is it a dotted line? Somebody raise your hand and tell me why it's a dotted line. Ethan?
Because it's less than and not equal to.
Okay. Because it's just a less than instead of a less than or equal to. The line is the equal to part. This one has no equal to part. Therefore, it's a dotted line. Are any of the points on the line the solution to the first inequality? No. Because it'd be something like this. Is 7 less than 7? No. Is 11 less than 11? No. The line is the equal to part, so none of them are true. But, remember, less than shade below. Didn't we shade below the green line? Okay, that's the green inequality. But we're doing a system. And we have a second one. So somebody tell me how to graph the second one, the blue one. Think. Graph the blue one. Kaylin, what do you want me to do first? Okay, so the y-axis. So from the origin, what do I do? No, from the origin to do the y-intercept. What do I do? How do I graph the y-intercept? From the origin, right here. I just want to make sure that you're telling me what to do. Do I go up 3, down 3, left 3, or right 3 to graph the y-intercept? Up. How many? Okay, just want to make sure. I thought you knew what you were doing. I want to make sure. Okay, I agree. That's the positive 3. And now, Kaylin, how do I do my slope from there?
Go down 2 and right 5.
So from that y-intercept, I go down 2 and to the right 5. So down 2, 1, 2, 3, 4, 5, to the right 5. Do you agree? Kaylin, do you want a solid line or a dotted line? I agree because it has the equal to part, right? Solid line. Lets you catch up. So again, you got a point at 0, 3. From there, you went down 2 and to the right 5. Put your second point. And now you drew your line through those points. Are we done with that blue inequality? We have to finish by shading a side. So, Kaylin, do you want to shade above the line or below the line? Because the symbol is what kind of symbol? Is it a symbol of greater than and equal to or less than or equal to? Greater. And greater than are values that are above, and less than are values that are below, right? Okay, so if you remember that, you're going to shade above. So I'm shading above the line. We have now graphed the two inequalities. Do you agree? Gotta get that stupid box out of there. Go away box. Can't get it to go away. All right. Go away. All right. Just gonna have to look at it. Oh, finally it goes away. So we have now graphed this system of linear inequalities. But what's the solution? Don't say anything. What's the solution? I want you to think about what we learned about systems. And I'll give you a hint. You really have to show the solution because you really can't say it. You have to show it. Anybody have any idea what the solution is? What is the solution? Ethan?
The point where it's both shaded, like where they're both shaded.
Okay, so like this point right there, is that the solution? I did it right there. Right there.
Yeah.
So that point?
Mhm.
Okay, so that's the answer. So the point 1, 2, 3, 4, 5, 1, 2, 3. The point 5, 3 is the answer. An answer. There's more? Well, what's another answer? Give me another answer.
5, 4.
5, 4. Yeah, okay, I agree. That's an answer. Anybody have another answer? Give me another answer. Andrew?
5, 5.
5, 5. Yeah, I think that's an answer. That one's getting a little shaky. 1, 2, 3, 4. Okay, 5, 5 is. I agree. Nope, that one's not shaky. Somebody else give me an answer. Nick?
4, 2.
4, 2. That's an answer. John?
4, 3.
4, 3 is an answer. Somebody else give me an answer. Raquel? 4, 1. 4, 1 is an answer. Somebody else give me an answer. Lauren, give me an answer.
3, 4.
3, 4. No. 3, 4. No. 3, 4 is not an answer. Sorry. Lauren.
6, 1.
6, 1 is an answer. Can anybody give me a negative x value answer? Give me a value with a negative x that is an answer. Come on, think. Eduardo. Negative 8, 1. Nope, not an answer, sorry. But good try, you were thinking. Give me a negative 8, 1. Give me an answer. Raquel. That's a y that's negative. I want an x that's negative. Eduardo, redeem yourself. No? You sure? Come on, give me an answer with a negative x value. Give me an answer with a negative x value. You know what? Some of your answers you gave me actually weren't answers, were they? Where are you? Where are my Kool-Aid people? Raise your hand if you're drinking Kool-Aid right now. All right, a lot of you are drinking Kool-Aid. All right, let's go back. Let me go back a second. Man, I'm messing you guys up. 1, 2, 3, 4, 5, 1, 2, 3. Okay, there was Ethan's first point. Somebody else give me another point that's a solution. I don't care where it is. Just give me a point that's a solution. Give me a point that's a solution. Adriana. 1, 2, 3, 4, 5, 6, 1, 2. Okay, I agree. That's an answer. Somebody else give me another answer. John.
4, 2.
1, 2, 3, 4, 1, 2. Okay, I agree. That's an answer. Somebody else give me an answer. Kaylin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Actually, I agree. That's an answer. Somebody else give me an answer. Give me an answer. Raquel. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. No, that one is not an answer. Somebody else give me an answer. Andrew.
Negative 1, 1.
Negative 1, 1. Nope, that one's not an answer. Somebody else give me an answer. Andrew.
Negative 1, negative 1.
Negative 1, negative 1. Actually, no, that one's not an answer. Okay, we catching on now? Look at what's going on, because hopefully you get it. You'll have it the rest of your life. Adam, give me an answer.
-1, 5.
Negative 1, 2, 3, 4, 5. Actually, sorry, that one's not an answer. Give me an answer. John.
Or 5, 5.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is an answer. Give me an answer. Kirsten. 1, 2, 3. 1, 2, 3. That is an answer. Somebody else give me an answer. Eduardo.
And -1.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -1. Yes, that is an answer. Does that help you to understand? Here, I'll even go this far. Does that help you to understand? Okay, somebody tell me why that's not an answer. Andrew.
Because it's like not the shaded area of the blue line.
Okay, so Andrew, this point would answer which inequality? The green one. Does it answer the blue one? And that's why it's not a solution. Does this point answer either one? No. Is this point a solution for either one? No. Is this point a solution for either one? Yes, the blue one. But does it solve the green one? No. And somebody earlier gave this point, it was right here on the dotted green line. Does that solve the green one? No, that's the equal to part. It does solve the blue. It doesn't solve the green. So the solution to the system is all the points of intersection. It's where all the inequalities intersect. So we usually darken it. So I'm going to shade it in red, right? It's all this area here. Any point in there. Hey, how about the point 1, 2, 3, 4, 4, 1? Is that a solution? Actually, that's not a good one to pick. Let's go 1, 2, 3, 4, 5. 5, 1. Is that point a solution? Yes, it's on the blue line, and the blue line is part of the blue, and it's in the green, right? So all where you see both colors. You got the concept? So that's what a system of inequalities is. You got to find where the shading overlaps. And the way you would do this in pencil is you will have to darken in that final answer. So if you're doing this in pencil, shade the first one lightly, shade the second one lightly, and where they overlap, darken it. Can you have more than 2 inequalities? Yeah. It would be where all 3 intersect. If you had 4 inequalities, it would be where all 4 intersect. If you have 5 inequalities, it would be where all 5 intersect. Okay? That's solving a system of inequalities. All right, so let's do a couple examples here and write a few things. All right, so remember, to graph, this is a review. Put the function in what form? Which is what? Y equals mx plus b. You cannot forget that. You cannot. And what do you plot first? The Y-intercept. This has been on every test since we've had this, right? The Y-intercept or the b, right? It's one and the same thing. And remember, from the Y-intercept, use the slope to get the second point. This is all review, right? We've done this already. Use the slope to get the second point. D, use a dotted if it's less than or equal to. Use a solid line if less than or equal to, greater than or equal to, right? And shade the solution. And there's your reminders. Less thans or equal to, you shade below. Greater than or equal to, you shade above, right? You can do a test point and all that if you want, but less thans are below and greater thans are above. Okay, so I'm going to pause the video. I want you to graph the solution to number 3, all right? Make sure you show your final answer. You can use color or you can use pencil. You might want to use pencil. This way you can fix your mistake, but it's up to you. I'm going to pause the video. All right, so how many? Yours looks like that. Okay. So the black one, y-intercept of 4, slope negative 1/5, down 1, to the right 5, dotted line, shade below for a less than. Blue one, y-intercept of negative 2, that's the point right there. Slope 3/5, up 3, to the right 5. Solid line, greater than, shade above. Where the black and the blue overlap, everything I shaded in red. Does that make sense? So how many got that right? Okay. We got to be, we just got to be careful with our graphing. That one was ready to go. Probably the only thing you got to be careful with is understanding that your slope for this one is a negative 1/5. Again, the top is always up or down, negative's down, positive's up. Positive 5 is right 5, down 1 to the right 5. Second one, 3/5, up 3 to the right 5. Okay? Any questions on that one, anybody? Any questions? Lauren?
Where did they really, I didn't really see where they intersect.
Okay, so I'll do it this way for you. I don't know how much of this red. Okay, good. It took away a lot. Okay, so here's the black lines. Here are the blue lines. Blue and black is everywhere between here. See, this is, blue is everything up, black is everything down. Here I have only black, no blue. Here I have black, blue, black, blue, black, blue. Up here I have only blue, no black. Therefore then, the places where there's black and blue is right there. Right there. Any other questions, anybody else? Okay, let's go to the next page. All right, let's deal with a couple special cases. I have to remind you guys what x greater than 0 means. That means every point of the solution has a positive x value. This is actually a vertical line on the y-axis. And do I shade to the right or to the left? Where are the positive x values? To the right. This is the graph of x greater than or equal to 0. Does not every single point where the blue is have an x value that's positive, greater than 0? You guys want to put a horizontal line because you see x. And you automatically think, x is horizontal. No. X greater than 0, greater than or equal to 0 means where are all the x coordinates that are greater than 0 or positive? And that's to the right. Don't do this in your notes. What's the x coordinate of that point? -1. What's the x coordinate of that point? -1. Those aren't greater than or equal to 0. What's the x point value of that? -2, -3, -4, -3. None of those are the answer. It's the ones to the right. Okay, so then can you do the next one? Can you do that one? What would you do for y greater than 0? How do you do all the y values? First off, am I going to have a solid line or dotted? Dotted. And where does the dotted line go? Like this, the y-axis? Is that what somebody said? Okay. It goes where? It goes on the x-axis. Because every point up here has a positive y value, doesn't it? It does. Every value up there has a positive y value. Who cares? Okay, I want to show you one more on this. I want to show you one more each. take a different color, probably use your red. Let's do two more special cases so I'm sure you're clear. Let's do x less than -2. My dotted line is going to go vertically or horizontally? And through what coordinate? X equal. And am I going to shade to the left or to the right? To the left. Isn't every x coordinate shaded less than -2? Does that make sense? Let's do one more on the y. You want to do greater than or less than? Let's do less than. Let's do y less than or equal to 2. Y less than or equal to 2. What would that look like? Do it in red. Would you agree? Y less than or equal to 2? Does that make sense? Isn't every y coordinate less than 2? Hey, what if this were a system? Let's treat this as a system. Where would you shade? Where do you see black and red? Black and red. Wish it were black and blue. Wouldn't you shade in here? And by the way, wouldn't it keep going forever both directions? Because those lines are parallel. Pretty cool. Capiche? Is that making sense? You're asking questions if it's not? I'm having the hardest time with the Algebra 2 class because nobody will ask questions in there. And they just stay in the dark. And when you're in the dark, it's no good because it's scary in the dark. All right? Don't stay in the dark. Okay. Hey, we have a system with 3. You say no sweat. I can do that. So now you got to grab 3 of them. So let's do them together so we don't mess up your pretty notes. Everybody thinking, what would you do to the blue one to get ready to graph it? Don't say anything out loud. Think. Look at the blue. What would you do? Somebody raise your hand and tell me what to do. Andrew? Okay, so I would have to, if I did this technically, I would add a -2x to both sides. Agreed? So here's where I'm at right now. -3y less than, and by the way, I'm going to put my x in front to just be more clear, y equals mx plus b. Does that make sense? So I'm going to do the -2x plus the 9. Is everybody okay with that? We move the 2x to the other side. So Andrew's right in that. What's the next maneuver to get this in proper form? What's the next maneuver? Antonio?
Divide by -3.
Right, and so remember, I got to divide everything, right? Everything. Every term on the left, every term on the right. And I'm doing an inequality. So I'm also doing what, Adam? Yeah, don't forget to flip the symbol when multiplying or dividing by negative quantity, right? Remember that? Okay, so now my left is a y. Good. A negative over negative is a positive, right? This is a 2/3 x. And a positive 9 divided by a -3 is a -3. Do you concur? All right, for time's sake, graph the y-intercept. That's -3 on the y-axis. Again, if you're forgetting, the vertical one is the y, the horizontal is the x. Go to -3 on the y-axis. Use my slope. Somebody tell me what to do from -3 to do my slope. Antonio?
Go up 2 and to the right 3.
I agree. Up 2 to the right 3. That puts me right there. So from -3, go up 2, go to the right 3, and put your point. Class, solid or dotted line? Dotted. All right, so I'm trying to line up and do a dotted line. If I had a straight edge, I would use a straight edge. Class, do I shade above or below? Above. Greater than is above. See, if you wouldn't have swapped your sign, you wouldn't know to shade above. Okay, that's the blue one. We've got a lot of room to work with. We know how to do x greater than 0, right? Man, don't scribble it in so dark because that's only the first one. We got to find where all three intersect. So now do your x greater than 0. That's a dotted line, right? Do I shade right or left? X greater than 0. Do I shade right or left? Where are the greater than values? To the right or to the left? To the right. Are any answers possible down here? No, because there's not blue and black. The only possible answers right now are where there's both blue and black, but we're not done yet, right? Got to do green. And green is a solid line on the x-axis. And we shade where? Below. Now, can you read everywhere where there is green, black, and blue? Well, if you're clear, you can. So just think of where everything is. So look, don't go past here. I always like to do the border first. I can't go higher than that, right? And I can't go lower than that. If I go higher than where I am in red right now, I'll run out of green. If I go lower than I am in red right now, I'll run out of blue. Do you agree? So I'll start going to the right. And I actually went a little too far, didn't I? Because I got to be careful. I got to stop right there, right? Because if I keep going to the right, I'm going to run out of which color? Blue. If I keep going right, I'll run out of blue because blue is from here up. So now I got to start running down along the blue, right? And that's the border of all three, and then I can come back in and color that in, right? So we get a little triangle right there. And hey, guess what? Don't lose this. Everybody watch now for a second. Don't do this. But look, here's the point of it all. Let's take this point right here. That's smack dab in the red, yes? What are the coordinates of that point? Say it if you know it. No, +1, -1, yes? Don't write this in your notes. +1, whoa. Come on, pen. +1, -1. Those are the coordinates. Agreed? Let's go to our originals. 1, -1. 2 times 1 is 2. -3 times -1 is a +3, right? 2 and 3 is 5. Is 5 less than 9? Worked in that one. Put in 1. Is 1 greater than 0? Worked for that one. Put in -1. Is -1 less than 0?
Yes.
Hey, it worked for all three. But again, isn't that what we were trying to find? The values that solve all three? Because isn't that what the shading is? Isn't the blue shading the values that solve the blue? Isn't the black shading the values that solve the black? And isn't the green shading the values that solve the green? So the solution to the system is the values that solve all three. And so we shade where you have green, black, and blue. Got it? Was that our last question? That was it. All right. Hey, get your homework down. We'll review on Friday, test on Monday. Use HCS math class. If you need help, use HCS math class.